Hello, students. Today I have a very good question under probability distribution, and specifically, I'm going to be talking about continuous distribution, and we are going to be using the model for the normal distribution to solve this question. Now, the question: the life of a certain make of electrical light bulb is known to be normally distributed with a mean life of 2000 hours and a standard deviation of 120 hours. Estimate the probability that the life of such bulb will be Roman figure 1 greater than 2050 hours, then Roman figure 2 1910 hours, and Roman figure 3 is a range actually between 1850 and 2090 hours. So let's move to solution. Now, please, in this question, there are things that I want us to note. We are going to be using the normal distribution table. Okay, for standardized scores, or we say for Z scores. Okay, that is what we are going to be using. Then 2, we are going to be looking at the normal distribution curve. Okay, this is going to help us to understand what the question is talking about and how to solve it. So quickly, let me move to the curve so that I can explain one or two things using the curve now. Now, this is a curve on the screen. It's a bell-shaped curve, okay, and it spans to positive infinity and negative infinity. Now, one thing that we need to know is that for a standardized score, we take mean, all right? We take mean to be 0 and the standard deviation to be 1. I'm going to be talking about this very soon. Now, the area under the curve, is 1. All right, so let's take note of that. The area under the curve is 1. So whatever it is, the area is 1, and it is 0.5 on each half. Here is 0.5 and here is 0.5, which makes it 1. Now, like I said earlier on, to standardize the scores, we have this expression, which is x minus mu all over sigma, which is standard deviation. And we need to know this, okay? The mu stands for the mean. Then the sigma, standard deviation now. Standard deviation. So since we've gotten this, we can now move further to actually solve the question. Now, the first question is we need to get the probability for having a bulb that is greater than 2150. Roman figure 1, probability such that x is greater than 2150. Now, we need to standardize the score, so we pick our z is actually equals to x minus mu all over sigma, which is the same as saying 2150 minus 2000. Yes, 2000. And if you wish to know, if you check out the mean. All right, the mean is 2000 and the standard deviation is 150. So take note of that. So let me write it here. Mu is 2000 and sigma is 150. So over 150. Now, doing this, we are going to have 150 over 120, and our answer is 1.25. Now, what we are going to do with this 1.25 is to go over to the table and find the area under 1.25. Now, I'm going to teach you how to use the table. So you follow me to see how to use the table. Now recall we said our Z is 1.25. Now what you need to do is to come over. Where is 1.2? Can you see my 1.2 here? So it's 1.2 under 5. 1.2 under 5. Look at it here. Okay, is 0.3944. That is the area. So let me go to the curve and teach you how to actually analyze this. Now this is the curve. You see the 1.25 we got in here is this. I'm coming here. Let's here be my standardized curve. Z is equals to 1.25. Now, the area which we found, which is 0.3944, actually signifies this area. Okay? This area. But is that what we are looking for? No, that is not what we are looking for, because we are looking for greater than. All right? Now, greater than signifies this area. The entire area here. That is our required region. That is where we are looking for. And remember, I said from the beginning that this half is having a total of 0.5. And what is that supposed to mean? For us to get the probability for x greater than 2050, then of course it will be 0.5 minus now 0.3944. Okay, because that is the required region, and the final answer will be 0.1056. Okay, that is what we need to do. So quickly, let me go back to the second question. The second question says greater than 1910 hours. Okay, let's analyze it and see. Okay, Roman figure 2. Probability of x greater than 1910 hours. So we standardize it. So Z is equals to 1910 minus 2000. Remember our mean, then over 120. Now doing this, we are going to have minus 90 all over 120, which will be minus 0.75. Okay, that is what we are to get. Now, going to the curve, this is what is going to happen. Okay, minus 0.75. Remember, this is this side is increasing to the negative, so let's say minus 0.75 is somewhere here. So this is where my Z is minus 0.75. Now, but if you check, we're talking about greater than. So it means that our required region will be everything here. Everything. Now remember that this half is already 0.5. We've said it from the beginning. So this is what we are not to look for. So we go to the table now and get the area under 0.75, just as we did in the previous question. Now Z is equals to 0.75. Now it is minus 0.75, but we are talking about area, so we just are talking about the absolute value now. So look at 0.7. 0.7 under 5. Under 5, can you see it now? Is 2734. 2734. So since we've gotten this, let's move back to the curve. So it means that this area is actually 0.2734. That's exactly what it meant. Now, the total area is addition of these two areas now. Hence, the probability of having x greater than 1910 will actually be 0.5 plus 0.2734, and adding it we are going to have 0.77, I think, 34. So this is the answer. This is what you should get if you do it well. Then quickly, let's go to the last question. The last question is a range. Okay, it's a range between 1850 and 2090. Now, Roman figure 3 is going to be probability so that x is greater than 1850 and it is less than 2090. All right. So if I were you, I will have two z's. The first one should be x greater than 1850. So you have 1850 minus 2000 all over 120 hours. Doing this will give me minus 1.25. Then z2 will be 2090 minus 2000 all over 120, and doing this will give me 0.75. Now, to really understand what you need to do, you have to go to the curve, you see what it meant, then you will now find the area and know the next step to take. Now the curve is on the screen. Remember, this increases from infinity, all right, and this is positive infinity. Now we have minus 1.25. So let's say this is where my z or z score to be minus 1.25. Then we have 0.75. Let's say here is my 0.75 area. So this is 0.75 area. Now remember, it is said that it is actually greater than 1850 but less than 2090. So the required region will be this. All right, will be this. And it's very simple. We will now go to the table and find the area covered by this. And we'll move to the table, we'll find the area covered by this. Now recall, in the first and the second question, I've shown you how to actually find the area. All right. So if you go to the table to find the area at this 1.25, you are going to find out that the area is 0.3944. We've done it before. Then at this 0.75, which we've done before equally, is going to be 0.2734. Now, since we have this, and from the curve, it has clearly shown to us that what we need is to add, then the probability for having our x greater than 1850 less than 2090 will actually be the summation of 0.3944 plus 0.2734. And if we do this, of course, we have 8, then we have 7, and we have 6, and we have 6, then 0 point. So this is what we have as our answer. It is a very interesting thing to do. I advise that you keep watching. Just watch over and over. Make sure you calm down to really understand, and you will never like drift again, okay? And don't forget to subscribe and keep watching very interesting maths videos. Please don't forget to subscribe, hit the like button, and make sure you make your comment if there is any. Thank you so much for being with me.